Hi there, this is Penelope. This is just a quick video just to go over question 19 in assignment 1. I've had a couple of questions about it. I did actually make an error in the two answers that I've sent out, but it's immaterial to your final answer, so you'll see the difference, you'll see the error here. Right, you've been given that and you've got to do some stuff with it. The first thing to do would be to rearrange x so that t is equal to x over u, and then substitute that into y. Now instead of t, we're going to write x over u minus a half g t squared, which is x over u squared. And if we rearrange that, x. Now what I've done there is I have written it in the form of a quadratic because now I want to compare it with the original type. Then we can see that a is equal to negative g over 2u squared, b equals v over u, and c is 0. If you go back to the class notes from T2C1 and look at how we complete the square. So if a x squared plus bx plus c equals then we can say that y is equal to a times x plus b over 2a squared plus c minus b squared over 4a. And just in case you didn't really understand what was going on with the completing of the square, we haven't done anything. We've added this term here, but we've taken it away over there. So we've done nothing. That's how completing the square works. And now, if we do that, then we get that negative g over 2u squared x squared plus v over u x is equal to, now I hope I've got enough space, negative g over 2u squared times x plus v over u over 2 times negative g over 2u squared, and that is squared plus nothing, because c is nothing, minus v over u squared over 4 times negative g over 2u squared. Now, being very, very careful, which obviously I wasn't the first time when I was doing it for a couple of you over the weekend, being very, very careful, then we end up with the right hand side being v squared over 2g minus g over 2u squared x minus uv over g. And it's not difficult at all, it's very easy to make a mistake by getting it wrong. Now what we've got is we've got a parabola. What we had was negative g over 2u squared plus v over u x. So we've got this as equal to that there. Now it's a parabola, it's a frowny parabola, so it's going to go like this. Now what we have to do is we have to find the maximum. Now looking at it written in the way that it is here after we've completed the square, the right hand side here is going to be maximized when you take off the smallest bit, when subtracting, well, actually subtracting nothing. So then it would be the highest point. In other words, negative g over 2u squared times x minus uv over g has got to equal 0, because that will be the biggest y value. If we take off the least, then that will give us the biggest y value, and the least bit, the bit that we're taking off, is the bit that's subtracted, and then from that you can see that x equals uv over g. Putting it on the graph I think makes good sense. So this bit here now is uv over g, and that makes this term 0 at the maximum. So at the maximum, y equals v squared over 2g with no further working. This is a question where you kind of think your way through. It's not difficult if you kind of don't overthink it. So this point here is v squared over 2g. So that, whoops, it's a weeny bit wonky, but that is the maximum. Now, what do you know about parabolas? Parabolas are symmetric about their maximum or their minimum, but in this case so if this point here is uv over g, then the point here is twice that. And the question asks you for the range, so it goes from 0 to 2uv over g. You could have solved y equals 0, because remember, y equals 0 on the x-axis. You could have solved that. You'd have got the same answer. Okay. Now for question 20. Question 20, use Desmos to draw it, or, so use Desmos, or set up a table. So you'd have had t, x and y, and just some random numbers of t, maybe 0, 1, 2, and maybe, I don't know, negative 1, negative 2, maybe negative 3, doesn't really matter. And you can do it that way, or you might have gone from that. So you might have the whole thing, might have variables from negative 5 to 5, that's fine. Now then it says x equals 2t squared over t squared plus 1, and y equals 2t squared over t squared plus 1, and show that y squared equals x cubed, I think is it's showing. Show that it equals x cubed over the square root of 2 minus x. Something like that. I haven't got the question. Yes, I have. So show that y squared equals x cubed over 2 minus x. Okay, this is what I said the other day. If you're going to prove something or show something, you start with one side. You don't kind of try and prove by rearranging. You just start on one side and hope like crazy that you will end up with what you need. So you would start off by finding T. Find T from rearranging that. Then substitute T equals whatever into there. Then be careful. It's not hard. Again, it's just easy to make a mistake, and you will then get to the point, you'll find Y, so that you get Y equals something, and then you can square both sides and get that. So you should, either if you do a table or if you use Desmos, you should get a curve that looks a bit like that. A bit like that. Right.